Hi everyone, I'm Camille Dupont. I'm a research engineer at CEA. And I'm going to present to you now the Pixano tool, which is a smart annotation tool that we developed for computer vision applications. And before starting, I would like to thank the Eclipse Foundation for the opportunity to do this presentation. It's a great pleasure to be here. And I'm gonna start now. So before talking about Pixano, I'm gonna give some information, some background on our particular lab that developed the tool to understand better the reason behind Pixano. So what we do in our lab is visual scene understanding. Well, to explain what it is, I'm gonna give a bunch of examples. The first example is detection. So we have a few images here where we see that we detect people. So we have bunny boxes around people, and we have also bunny boxes around some objects. So that's what detection is. It can also be localization. We want to localize the person. So we want to localize it in the image, but also in the real world. So is the person very far from the camera? Is it very close to the camera? And want to also track people or objects. Why do we want to track people or objects? For instance, if we want to follow a ball in a football match, we want to know where it's been, to analyze maybe where it's been, if it's been in the team A or team B. We can also follow people, maybe we want to know if they are going towards the camera, if they are very far, or if they are in danger, and so on. Another very interesting thing that we can analyze in images is the finer description of all the objects and persons. So we have an example here. We have persons that are in a train station, and we want to know what they are doing, if they are carrying a bag, maybe if they forgot to take a bag. It's a lot of things that we can describe in the scene that we do in the lab. Another application is the re-identification of people. If I use the example of football again, we want to identify a certain player during the match. And to do so, we can detect the face. If we don't see the face, we can maybe detect the clothes extra. And the last example I'm going to give you is the analysis of the behavior and the activity. So we see on the left, we have an image where we want to detect the violence in a scene, and another example on the right where we want to analyze the activity of a person, maybe in a retirement home. We want to make sure that the person cooks and eats and does a lot of activities that we want to analyze. Now I'm going to talk about Pixano. So what's the link between all the applications I just showed? So for each single of those use cases and algorithms, we require a lot of annotated images. What is annotated images? It's images that are enriched with information such as bounding boxes, as I showed before, or maybe a mask, a very fine polygon around each object, and so on. And these annotated images are very, very important in our lab. It's considered the gold even of the 20th century. And it's why it's important. It's crucial for the training of the artificial intelligence models, especially in supervised learning. It's also very necessary for the evaluation and validation of the algorithm, as it's been said previously by Christian. And for those two reasons, it's really a requirement in most of our projects in the lab to have annotated data. Whether it's for little project with very new and innovative applications, or for very mature projects such as autonomous vehicle, where we want to make sure that the algorithm works well in Paris, in Japan, whether it's night or day, whether it's a good weather or not good weather. So the challenge for this specific need, the challenge is to have a tool that allows us to well annotate all those applications, whether it's detection, tracking, and so on, to allow us to do that, and also to facilitate this task, because it's very, very long, as you can imagine, and we want to insert some intelligence in the process to accelerate the process. Hence, Pixano that does exactly that. It's a tool for the annotation. It's a smart tool to help annotators annotate more efficiently. And it's a very modular tool that we wanted to that I underline here, because it's very important in our field. It's a huge need that we have, because well, the applications, they move very quickly. The algorithm, they upgrade every 6 months. So we need to have a tool that is very modular and flexible, that can progress very fast, so we can keep up with the algorithm that we want to generate annotation for. So that's about modularity. Another important point is the interactive system. So as I said, we wanted to input smart and algorithms in the annotation tool. And it's not very easy thing to do, because as I said before, AI algorithms tend to need a lot of data to work well. And in our particular case, we actually are doing the annotating data. So we need algorithms that work well without a lot of data, or that are able to adapt to new kinds of objects that they have never seen before. So it's not an easy task. And last point about Pixano, it's of course the open source part. So we released this year the code of Pixano in open source, so most of the features. And why we did that? We did that in order to, well, to go faster, to make use of the community, to accelerate the development of those AI annotation solutions. To give just a little bit of history on Pixano, so I said it was released this year, and so it's very recent, and it was actually built and conceived the last 2 years. To be precise, it was during the Horizon Europe 2020 project that we developed this tool at the beginning. And yeah, it gave us the frame and the resources necessary to go from some, well, little annotation tool that we all have in our lab to this Pixano that we currently have online on GitHub. Just a few words on Pixano without going into details. I just want to present the tool a little bit and give the key features that it has. So in a few words, Pixano, it's a web technology, it's a web tool. What does it mean? It means that we have a lot of annotators that can just connect to their browser and open the application and annotate directly in the browser. So it's a popular technology in nowadays, because it doesn't require any installation from the annotators. And we have here so different browser here, and they are all served from a web server. Yeah. Now, more about the client that I just showed in the browser. How did we develop Pixano in the browser? I'm just going to talk about one key point about the border. So we used a web component to develop Pixano. Why do I talk about web components? Because it's a very useful tool for developing and using. So it's a standard that's included in the HTML specification. So it can work in any border, whether it's React, Angular, or just native JavaScript. To give an example of what is a web component, that's just a few lines of code. It's not too much. It's just one example. In the blue square, I showed how to in HTML how to present an input box where we can write stuff. That's the usual way we do in HTML. And what is a web component? It's the same. We just import the library. And we use the web component just as we would use a regular HTML tag, except it does things a bit prettier here. We have a better box for inserting the text. So Pixano is basically the same thing. Instead of just displaying a nice input box, we're gonna display images or videos that we want to annotate. So here's an example. We have a web component here that displays an image. We can just draw polygons around each tool in the image. So that's the polygon tool. We also have the segmentation tool for more precise applications when we require that each pixel in the image has a category or instance. So we have in the left, we have the semantic segmentation where we want to know every pixel that belongs to a car or a person or a word, etc. And in the right, we have instance segmentation where we want to know, okay, this pixel is from this person and this other pixel is from another person. Another example of a Pixano web component is the LiDAR annotation. So I don't know if I can see it well here, but we have a cloud of points, of 3D points that is often used in autonomous vehicle to detect maybe objects that are near the car, to alarm the car that it's near an obstacle. And we more and more want to use this sensor to apply machine learning and deep learning algorithm. So obviously we want to annotate those data as well. So for instance, we want to draw bounding boxes around vehicles, persons, and so on, just like 2D annotation. Alors, that's it for the presentation. Now I'm gonna show a quick video to explain better and to show a bunch of demos. Can you all see the screen?
Yes.
Yes. Okay, perfect. Just comment a little bit to emphasize a few points in the video. So now I just showed the instance segmentation, interactive segmentation more precisely. So we want to help humans to, instead of draw very precise polygons around an object, to just draw bounding boxes and fit automatically the mask inside the bounding boxes. And the requirement for this type of algorithm is to work for any object, of course, because we want to annotate new types of objects all the time. So for instance, this algorithm has never seen a tomato before, but we want it to work on tomatoes as well. information about NPM. For those who don't know, it's a very useful registry that is available in internet. It's just like for those who use Python, it's the equivalent of pip packages. So it's very important for us to be present on such registries, so that people can well try our tool very easily in just a few commands on the terminal. They can have the tool and try it and test it. So they want to maybe contribute and go on our GitHub later. And that's all from our presentation. I just wanted to share the links where you can find the tool and the demo and some documentation. Thank you very much.
Thank you, Camille. Thanks to all the speakers. Thanks, everybody. So first of all, I'm sorry that it looks like I was a bit optimistic in terms of the content we can fit in 2 hours, and also that's, you know, that with this this 2020 year, we all have to do things a bit differently, and so that's still about learning virtual events and the fact that you cannot interrupt speakers in a virtual event or show them a tag that says, hey, you still have 3 minutes or stuff like that. But I think that we had very interesting presentations. So let's start maybe with the question that Boris put in the Q&A for at the beginning. I suggest that we take maybe 10 minutes together to wrap up the conversation, and then we have to think if maybe we have enough material for another format with no slides, but only no introductory slides, but only a discussion. That could be a follow-up episode of this episode on trust and AI. And just to start, and maybe that's Camille, we need to work together on bringing Pixano as an Eclipse project, because I think that it's good to have it on GitHub, but that would be even better to have it in an open source foundation. So that's just to close my part of the.
That's a great idea.
Yeah, let's have a call about that. I see a few things we can do together. François had to leave, but that's certainly something worth working on. So Boris told us that, and maybe everybody can reply to this question. How can we do we have examples now of how to justify AI results, and like a known framework or a practical implementation, or is it still too early, too much a research level field? Jean-Claude? Or Nicolas, maybe?
Yeah, maybe Nicolas has the answer because I don't know exactly. That's for us. It's for now pure research, and I haven't seen up to now anything related to practical implementation. Let's say something on GitHub or in any other place. I don't know, Nicolas. Probably you know much better than me this. How to answer.
What I was going to say is that in terms of justifying AI results, so in terms of explanations, we do have this logical technique. We've made it work only on really quite small small neural net systems. Because we work very closely, it's too bad that Christian is gone, because I wanted to say we work very closely with our industrial partners. So we have a lot of interaction between data scientists and more academic foundational research. We are working at doing explanations of a system for Renault for blinking, on car blinking data. So whether the car is turning right or left.
Okay.
And we've also used the technique on runway landing requirement data given to us by Airbus. But these systems are still quite small that we were looking at, and well, actually, also we have statistical techniques that we use. My main feeling, the problem is the logical ones give us valid explanations. We know that there's an entailment relation, but they don't scale up very well. The statistical ones are very efficient, but we don't have formal guarantees. And what I think the next real hurdle is to put those two ways of thinking about this together. And
yes.
And I think, Jean-Claude, yeah, you also were going in that direction.
Yes, exactly, because we are not, in fact, what we have done is not, to implement some symbolic neural networks as it was done in the maybe 90s, 80s, 90s, I don't remember exactly. It's something completely different. We have really used the let's say even if they are small, you're right, you're totally right. Even if for now our neural networks are small, there are neural networks that are in fact deep neural networks, and so that's which are trained exactly as the regular ones that we know now. It's not something, we haven't done any let's say symbolic assumption at the beginning. We have just used the classical inputs that are currently used now for the regular neural networks that we know. So that's why it's rather, as you said, it's rather an hybrid, something hybrid, which aim at using both. The statistical approach, and what we have seen is that using the statistical approach, we finally came up to a logic behavior in the examples that we have tried. Of course, I'm not saying that it's super general, but so it's a first step towards, I hope, something in which we can really let's say in which the good aspects of both can meet at the end of both approaches. Sorry, can meet at the end.
Jasmine, do you have any? Do you think that there is some stuff some answers in the AI assets of AI for EU on this topic? Or? You're on mute. You're still on mute. I see you.
Yes.
Yes.
All right.
Much better.
Forgot that. Sorry, I could not hear what you said before. So yeah, as I told you in my short presentation, the AI for EU project also deals with explainable AI, or one of the pillars that they are working with, that we are working with, or dimensions. And there are several well, all in all, it's like more than 80 partners, and several of them are also included in explainable AI, in only the explainable AI topic. And what they are doing there is, first of all, to identify the gaps that are still there in AI. But then it's also about connecting use cases or pilots, as they are called, and trying to solve concrete problems, and from there go on and see what can be generalized. And I know that they are working on, one of the pilots they are working on is in AI for healthcare, and I know that they are, well, the pilot is about detecting skin lesion of melanoma, so detection of skin cancer, so to say, and to see. And the other test case that they have, or pilot, is to have explainable predictive maintenance. And predictive maintenance is maybe, as you know, to foresee when some machines in some factory will have to have maintenance in the future. But yes, so the exact details of all the backgrounds of how they approach these problems, I'm not so deep into that, but I suggest everybody can register at the AI for EU platform, and you know the link. And when you go into the AI repository, there is a catalog, and there are assets online that are addressing this issue.
Yeah. Okay, thanks. So we have another question, and maybe that's the last question. Okay, so we have another question. So during the Europe RNI days, the lack of resources in EU was pointed out. Is there any open source program or idea to train, teach IT experts in AI, machine learning, and in short time frame bridge the gap of this obvious lack of resources in EU? So that's, I can give my opinion on this one. I think that one of the weaknesses of Europe is that there are certainly plenty of open source AI projects that are developed by Europeans that are pushed to GitHub, like I was just mentioning at the beginning. And I think that certainly the most actionable thing in a short time frame is to put people together around the same platform. So that can be AI for EU, even if I think that in AI for EU there is open source, but there is more, and that's typically the kind of discussion that I have with AI for EU to try to set up a partnership between the Eclipse Foundation, where we focus only on open source, and AI for EU. And that's really also what I try to set up at the Eclipse Foundation, not with the idea of restricting it to Europe, because the Eclipse Foundation is a global organization. We have always been a global organization, and we will always be a global organization. But with this idea that we are the main open source foundation in Europe, and we can certainly help Europe have a better visibility and better outreach in AI. I think what I see for the moment is that everybody who wants to learn AI more or less ends up using TensorFlow or this kind of technologies, and we can certainly do better from a European point of view. Nicolas, you want to add something? You're on mute.
Yes, I just wanted to say that one of the aims of the 3 AI institutes in France, the 4 of them, is to actually have a big educational effort, both at the initial education, so to greatly expand the availability of AI courses to students in French universities or at those centers, Paris, Nice, Grenoble, and Toulouse. And also, we're very committed to vastly increasing our continuing education programs so that engineers at our partner companies, but others can also come in, get training. A lot of that, we're still working on this, is getting virtual training. And then maybe Yasmin can pick up on this too, but we're part of an ICT 48 project with the Claire Resource Institute, and I think they also are committed to large educational outreach, but maybe you can say something about that.
Yes, so already now it's, so ICT 48 will be for future calls, but already now there is a educational space planned on the AI for EU platform or on the AI on demand platform. It's, as far as I'm informed, not launched yet, but as I said, it's this platform is growing, so it's coming. And I'm pretty sure if somebody is interested in getting any sorts of education, this is a good point to go to as a first step, and the contents there will grow and grow. And as Nicolas also mentioned, ICT 48 is also relying on this AI on demand platform. So even after AI for EU, it will be growing, and it will be extended and enriched. So I think this is the vision, one of the visions of the AI on demand platform, that also students, for example, not only AI experts, can go to this platform and register and get in contact, and also find material where they can actually learn something.
Good. Cool. Thanks, François. So, well, I think we are done for today. Thanks for your patience. Thanks for the good content. I just posted a link in the chat because we created an AI@eclipse.org mailing list. I think that you should also go to AI4EU.eu. That's EU, and register on the platforms, and you receive some interesting notifications regularly. So join the mailing list so that we can continue the conversation. Stay tuned, because you will receive an email with the videos and more information. And join AI4EU, and well, looking forward to having you. Oh, okay. Sorry, I put it only for the speakers. Okay, here you see it. You should. And well, thanks everybody, and looking forward to a next edition and the next opportunity to discuss together. And maybe I will invite you, and we have this panel discussion that we didn't have time to have together, is October 19 afternoon.
Okay.
Thanks.